This is Physics 2, Lab 2, Lines of Charge, and my name is Anjana Iyer. So, the purpose of this experiment is to determine the excess charge on a piece of tape while treating the tape as a rod. We also want to understand how to calculate the total charge and then compare those results with the previous lab to identify the key differences of viewing the tape as a single point charge versus as a rod of charges. In a preview of the results, the excess charge was calculated to be 1.9625 times 10 to the negative 3. So the physics principles in here, the main fundamental principle that was used in this lab is Coulomb's law, which states that the force is equal to K times charge 1 times charge 2 all over the magnitude of r squared, with r being the distance between the charges and K being 9 times 10 to the ninth, or 1 over 4 pi epsilon naught. The electric field formula can be found using F equals QE and rearranging to achieve the equation shown above. Newton's second law is significant here, and Newton's third law is also demonstrated in the sense that for every action, there's going to be an equal and opposite reaction. And this is important to understand since tapes ripping apart will cause a reaction on the charges of each tape. I also want to mention superposition, since that's what allows each electric field to be added together. And for the lab setup, the initial conditions, there's only two forces acting upon the tape, which are the force of gravity and then the electric force. And then the system was taken to be tape B, and then surroundings were tape A. And some assumptions we made in this lab were to ignore air resistance, assume each U-tape has the same charge, and assume that the charge of each U-tape is evenly distributed across the length, that the U-tape is divisible into equal infinitesimal lengths, and that the charges of each segment summed up will equal the total charge of the entire tape. And then here's the code for the lab. The constants were initially defined at the top, and then the charges from lab 1 were also noted. The electric field is then calculated using kq over the magnitude of r squared times r hat and applying the principle of superposition in the for loop. I think that's on line 50. The net electric field by the tape can be found, and we can come to the conclusion that F grav equals F electric. And then here the changes in the top tape and the bottom tape are calculated, and the arrows are consequently formed. The final result is showed on the right-hand side, yielding results of the electric force being 1.9625 times 10 to the negative 3, and the gravitational force being 1.962 times 10 to the negative 3, which are approximately equal in magnitude. In conclusion, line charges are going to be more accurate, but are also more difficult to calculate, and then Coulomb's law is what allows us to calculate the electric field and force. And some error we may have encountered in this lab is that the tape's charges may not have been evenly distributed along the tape. Each tape may not have had the same charge due to some human error, and only gravity and the electric force are taken into consideration, and that could cause some issues. And then the what if and why. What if you had modeled each of your tapes as a single point charge, like in the previous lab, compared the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model? The value determined from lab 2 was approximately twice the value determined from my first lab, and if the model of the point charge were to be implemented again, the charge on each tape would be much less. And why do these estimates differ? Which value is more likely to be closer to the real value, and why? I said that these estimates are going to differ because a point charge assumes a concentrated charge, while the other model is going to assume that the charges are evenly distributed. And the value calculated from this lab will be more accurate since it represents the evenly distributed charges, since charges are going to tend to spread out on the surface of the tape. And that's my presentation. Thank you.